Hey guys, welcome back. Hope you all are doing well. This is Muhammad Badruddin back again with another lab from Insecurity Serialization. So this lab description is saying this lab uses a serialization based decision mechanism. If you can construct a suitable gadget chain, you can exploit this lab's insecurity serialization to obtain the administrator's password. Now to solve the lab, we need to gain access to the source code and use it to construct a gadget chain to obtain the administrator's password, then log in as administrator and delete the Carlos account to solve the lab. We have our credential. There is one note that solving this lab requires basic familiarity with another topic that we have covered on the Web Security Academy. We need to also find out some other exploit, some other vulnerability, and that's why it's saying you need to have familiarity with other topics also. Fine, that's not an issue. So let's see the hint. It's saying to save you some of the effort, we have provided a generic Java program for serializing object. You can adapt this to generate a suitable object for your exploit. If you don't already have a Java environment set up, we can compile and execute the Java program on this website. This is basically, this will provide you the Java environment where you can compile and execute the Java program. Okay, although we will do it on our system. So let's go. I'm going to access the lab, but before accessing the lab, I actually want to see the generic program they are providing. So click on it. This is the project where they provided Java and PHP generic custom gadget chain according to the lab they created. And here if you see within Java there are two. One is generic and one is solution. The solution one is basically the actual solution and custom created gadget chain according to the lab. And the generic one is also the custom gadget chain, but if you use it you have to write the code or you have to make some changes according to the lab. So if you want to see the difference, you can see there is foo.java, but if you see in the in the solution there is product.java, right? And there is product template.java. So this one, solution one, is exactly created according to the lab. Although if you see the main.java from the generic, you will see everything is same. This is the generic custom created, but there are few things uh, you need to change here according to what you got in the lab. I already downloaded this and I will use exactly the solution to save the time. So to clone this repository, you need to click on serialization example, and from here you need to clone it, and you can go to your terminal and you can write git clone and you need to paste this, so it will clone the complete repository. Although I already did it, so I can show you here. So this is serialization example where we have Java and PHP, and within Java we have two repo, one for generic and one exactly according to the lab. Okay, so let's go back here. I'm going back to my lab. Okay, now I want to enable the proxy on my browser and just access the lab. So this is our lab. Let's go. I'm going to log in. So WIENER Wiener and the password is Peter. Hit enter. Fine. So we are logged in. Let's see the session cookie. I'm going to send this request to the repeater. Go to the repeater, send the request again. Here first of all I see the cookie. So it seems like it just decoded this URL encoded value. So I'm going to copy it, go to the decoder, paste that, and if I do smart decode, it's showing us nothing, so we need to make it manually. Choose base 64, and as you can see here we have object named as access token user. This is the object, and that object contains two attributes, access token is the first attribute and second attribute is username. This is the value of access token and the username value is winner. I want to go to the repeater and just try to analyze the response source code, so that because in the lab description it's saying we need to check out the source code. So first of all we will try to access the source code so that we will have more visibility and we can find out something interesting. So in the response source code you can see there is one file named as access token user.java, and this is exactly what you see here in the decode section, access token user from here to here. Okay, so access token user, I'm just going to copy this part and we are already in the repeater, so instead of this I want to access this exact file, and this is the source code of that file, but something is not correct here because there is no space. So I'm going to copy the URL and open the new terminal here, paste that, hit enter, and it's downloaded the file. So I'm just going to, yeah, now it's more readable. So you can see the package name as data.session.token, and also it imported a class serializable, and this class access token user is serializable containing two attributes, one is username and another one is access token. Okay, and now you can see here it's using two attributes, arguments, one is username and one is access token. So this is basically what we saw in the session token as the session token, as the session cookie. Fine. And the structure is same like that. Nothing much interesting here. We already understand it, but this is not what we are looking for, because by seeing this you have idea what it's doing, but there is nothing to do with that now. Let's see something else. So here you can see as we have this file access token user.java exists within the backup, so maybe there are other files also. So yeah, there is product template.java, so I want this file. Let's open this file also, and this file have much interesting things. So this package is data.productCatalog. The most important part here, which is interesting for me, database connection string, and you can see this is the class for it. Also serializable class is being used, SQL connection class is being used, SQL statement class is being used. So that's why this is interesting for me. So if we see here, you can see this is JDBC connection builder. This is the port number for the PostgreSQL. It's trying to access from the local host. And the more interesting part here is it's actually running this SQL query. So select star from products where ID is equal to, this is the parameter argument, whatever ID is provided it is going to be mentioned here with limit 1. Or one more thing which is most important I would like to mention here. So you can see the product template contains two fields. The first one is ID and the second one is product. Okay, but the thing here is the product is transient. So if you remember in the very first video where I explain about insecure deserialization, and in the prevention part I mentioned that if there is any attribute that contains the sensitive or critical information and we don't want that attribute to be a part of the serialization, so at that instant we need to explicitly control that thing. So we don't want, if we don't want that particular attribute containing sensitive information being a part of serialization, we have to use transient with that particular attribute. So this transient means the product will not be a part of the serialization, and you can see here also it uses only id. Now we have what we need. Come back to the solution and go to the data, and within product catalog I want to open first of all java.product. So you can see this class added just so that product template can compile correctly. There is nothing, just a class. Okay, and where it's mentioning the package data.product catalog and the class name is product. Fine. So this is just created to for the product template compilation. Now the main thing here, the product template.java, but this is what we access from the application, and this is what we have in the um, custom gadget chain. So if you see both of these files, okay, so this file is basically created what we see in the application. Okay, but what happened, we actually don't need this connection string, we don't need that connection string, we don't need that SQL query. Also from this file we know that the product will not take participation in the serialization deserialization process. So we just have, or we just need this id, because once we craft the session cookie, malicious session cookie, at that instant we use the id parameter as the injection surface, so that whenever that query is being processed, it is going to execute this particular SQL query. We don't need this here, and that's why we deleted all the things from here. So let's do it here. I don't need this. Okay, I delete that. Fine. Now I don't need all of this. Just wait a moment. Sorry. Okay, I also don't need anything from here up to here, and I also don't need this section because product is not taking participation in the serialization deserialization. So this is what we need only, and because we are not using here the connection string and the SQL statement, so we also do not need this part, result set, this part. Actually both of these we don't need that. Also I don't need this JDBC, and if you see here we are just using serialization, so we also don't need both of these. Fine. And now if you match this file, what I manipulated and what we got from the GitHub from the Portswigger side, you will see both of these are same. Now the thing here, I don't need actually this, I don't need that also, I don't need that. The second thing, let's try to see what's inside main.java. So within main.java, first of all, we just imported all the necessary classes what we needed. And as you can see, main is the initialization point. You can see here we can put our payload. This payload will be inserted within the SQL query we just saw before. And here it's creating one object, and then it's going to serializing that original object. So once it is serialized, you can see it is going to print the serialized object. We will see that in our terminal. Then again it is going to deserialize the serialized object, which we see here, and this again it will going to print out the deserialized object ID within the terminal, means in our command prompt. We will see that in a minute. Now this part is most important. So this part basically what it does, a byte array output stream, which is this, and BAOS stands for byte array output stream. So a byte array output stream is created to actually hold the serialized byte array, which is 512 bytes. Okay, and then an object output stream, which is this one. Here it's byte array output stream, and this is object output stream. So this object output stream is used to write the object to the byte array. Okay, BAOS, byte array. Writing here. Okay, and then what it's doing, the byte array is then base 64 encoded to produce a string. Okay, which is returned here with the return. Fine. Now the serialization process is done. Here it's about deserialization. So within this, the base 64 stream, what we get from the serialization, this base 64 stream is decoded back here and reconstructed into the original object state. Fine. And the object is reconstructed from the byte stream and cast to the expected type. So this is what happening here. Fine. So let's go without wasting time. I think I already took much time explaining this, but fine. So back to the burp proxy. I just want to refresh it to see if the lab is still alive. Yeah, it's still alive. Fine. So now everything is clear. We just need to now compile the program, and then we need to execute the program so that we can construct the malicious cookie. So which Java version I have? -- version. Let's see. Oh, sorry, I write the wrong spelling. Java version. So I have Java version OpenJDK 11.0.7. So let's try to compile this one, main.java. Okay, and for this purpose I'm actually going to first of all cd/opt custom deserialization example within Java. I want to use the source one. Okay, and then let's compile it with Java C, and the file name is main.java. So compilation is now successful. If we go back to the directory, you will find here new file is created, which is main.class. This file is created once you compile the Java program. Okay, so now the compilation is finished. Now we need to execute Java main. Okay, and there is a problem, and it's about the version. So if you face the same issue, actually I already fixed this, but I want you to know if you face the same problem. So for that purpose, you can come here and you can search for OpenJDK, and you can just open the first link, and then you can download here latest open source JDK 24. Click here, and then from here you can download for the Linux 64-bit. So I already downloaded this one, then I extracted this into the download directory. So if I show you like root downloads JDK, so once you extract that, there will be a directory named as JDK24, and within that directory there is another directory bin, and within that you will find all the binaries. So first of all, I want to compile the main.java file again, because if you do not compile it with the new version, it will again give you the same error what you see here. Okay, so compile it again, and let's try to run it with Java only. Okay, main. Okay, hit enter. So now you can see the payload is generated. The session cookie, we will use it as session cookie. This is generated. Now you can see here serialized object and deserialized object are printed here. So this is what we saw in the main.java. So this is the serialized object, and this is for the printing the deserialized object ID. Fine. Now our purpose is to put here the payload. So for SQL injection, I will not go much deeper into the SQL injection. I will just use the payload here because I already recorded the complete SQL injection vulnerability module. You are most welcome to visit my playlist for SQL injection, and from there you can gain much deeper knowledge. But here I will just give you very high level overview about whatever payload I'm going to use. So the first thing, once you try SQL injection to break the query, so that you will get some kind of error, and in that way you will know that okay, whatever payload or whatever query you are writing here is actually executing with the application SQL statement, and that's how you know that okay, this is the place where I can write my additional SQL queries. Fine. So let's see. I'm going to just put here single quote and double dash. So these double dash are comment, and this is to just break the query. And I'm going to save this file and go back here, clear everything, and let's every time when you make any change, you need to compile it and then you need to execute it with this. Okay, now this is our payload what we put here, and this is the generated result. So I'm going to copy it with Control Shift and C and paste it within the place of session cookie. Paste that and hit send. So now you can see 500 internal server error, but if you scroll down you will find here Java lang class cast exception cannot cast data product catalog. Fine. So this is perfect. I want to see how many number of columns are there. So for that purpose you can use two ways, with union select or order by. So I'm going to use order by, let's say order by 1. So if it contains only one column, it will give us the same error. Okay, so I want to check if it's contain only one column. So save it and back to the terminal, compile again and execute the program. Now this is our payload. There is one equal sign, so make sure I will just leave here one equal sign. Okay, send it. Fine. And if you see, the error is same. So until you exceed one column more than the exact number of column, it will give you the same error. So let's see, there are 10 columns. Just imagine there are 10 columns, and let's try to compile it again and run it again. So you can see this is the one we need. Copy it and paste it here and send it again. And now you can see order by position 10 is not in the select list. So that means we already exceeded the exact number of columns. So let's make it 9, save that and back again, compile again and execute one more time. Now this is the payload with one equal sign. Don't forget to copy equal sign, and if you do not copy, you need to put it here manually. Send it and let's see what happened. And still 9 is actually not exactly the number of columns, and it's still exceeded. So we will do it now. Let's say 8, save it and back to the terminal, compile it again and run it again. So this is our serialized object. If I copy that, paste it here send, and this time you can see the error moved on. So if I go back where I put 9 columns, it gives us the error that order by position 9 is not in the select list. But if I make it 8, it's saying it's not saying that 8 is not in the list. That means exactly 8 number of columns are there. Now we can use union select, and we will try null comma. Actually, let's just copy that and paste. So 1 2 3 4 5 6 7 8, that's what we need, because 8 number of columns are there. Now there are different things. If you go and study the SQL injection attack, there I explain how you can find out which column has which data type. So you can also find out the exactly column containing which kind of data type, so that you can query the same data type data from the database. But here I'm not going to demonstrate that, but what I'm going to do here is, in this column, if I try to say version, because we already know that the database used here is PostgreSQL. Let's try to find out which exact version of PostgreSQL is being used. So I'm going to save it now, and let's just clear everything and compile it again, run that again. Okay, so this is our generated payload. I'm going to copy it and paste it here, send it. Let's see what we get here. So now it's saying this time union types integer and text cannot be matched. Fine. So that means for that purpose we can use cast. So cast version, and we can say it as numeric, right? This is exactly what this error is saying. Cast is used to perform conversion between two data types. Okay, so suppose that we have a string and we need to convert it into the float or numeric or integer, so we use cast for that. So save it and just compile it one more time and run it. And I'm going to just paste that here, send it, and you can see, boom, this is a version of the PostgreSQL. Now if you know the version of PostgreSQL, you can directly go to the exploit database and you can search about this particular version of PostgreSQL and the related CVEs, and you can then try the CVE according to the situation what you have at that moment in front of you. Although that is not our purpose right now. Let's go now. I will try to exfiltrate some data from here. So instead of this version, this time I'm gonna say table underscore name. So I want to know the table name, but for this purpose I will say from information underscore schema dot tables. Okay, so this is how we can get the table name. Fine. Save this and back to the terminal, compile again, run again. So copy and paste that here, send, scroll down, and you can see within the quotes, this is the HTML encoded value of quotes, and within the quotes we get the we get the information what we try to exfiltrate. So the table name is users. Fine, we get the table name. Now we need to find out the column within the table. So instead of table name, column column, and here instead of tables I want to say columns, and we need to write here the condition where table underscore name is equal to what is the table name. We need to put it in single quotes, users. Users is the table name. Fine. So save it and compile it again. Run it. And this is the payload what we need. So copy that back to the burp and paste the newly generated session cookie, paste it here, and as you can see the column name is username. So column name is username, so users is the table name, column name is username. Now maybe the other column name is password, maybe the third column name is email ID. We need to check all of these. So now I want to know the username, and for this purpose I don't need this actually column name. I will just ask for the username, and we don't need everything here from users. That's it. So I'm saying what? I'm saying give me the username from table name users. Okay, so save it and back here I'm gonna clear everything. Now compile and run it. So this is the final payload. Copy that, paste it, send it. So you can see the username is now administrator. Now we just need the password. This is the final step. So instead of username I'm gonna say password from users, where the username is equal to administrator, because we need the password for administrator. So we are asking for the password from users table where the username is administrator. Save that and back to the terminal, compile, run it, and just copy that back here, paste that, okay, send it, boom, this is the password. So I'm just going to copy this and paste it. Fine. Now the username is administrator and this is the password. Fine, just go back to the application, log out from Wiener user, log in from the administrator account. So administrator, and the password we just have here, paste it here, hit enter, don't save, and you can see we are logged in as administrator. We have here admin panel, just delete the Carlos account, and we solve the lab. So hope you enjoy the lab. I'm going to see you in the next video. Bye.